This is Fat Man, a code name for the second and last nuclear weapon ever used in the war. Hello everyone and welcome back to Discovery Zone. The bomb ended World War II, killing almost 40,000 people. It was one of the two nuclear bombs exploded over Japan. The world witnessed the destructive and devastating power of the nuclear weapon. In this video, I will take you on a detailed tour of the inside of the plutonium implosion bomb. We will talk about the science and engineering behind the weapon and the series of events that happened before the bomb exploded. Have you ever played the game of Jenga? Let's say you keep putting blocks one over the other. The more blocks you put, the more unstable it becomes. If the height of the stack is too high, then a slight force will collapse the entire structure. Similarly, the more protons and neutrons in the atom, the more unstable it becomes. All elements heavier than lead are usually unstable. They decay eventually and convert into lead to lower their internal energy. Some materials and their isotopes, like uranium-235 and plutonium-239, are called fissile materials because their atoms can be split. In the case of plutonium, if it is supplied with a small energy by colliding with a free neutron, the already unstable nucleus of the plutonium atom completely splits into two smaller atoms, xenon and zirconium. This is called nuclear fission. This fission or splitting of the plutonium atom will also release 3 more neutrons. If these neutrons collide with other plutonium atoms, they also split them, and the reaction continues. At room temperature and standard conditions, the plutonium sphere is kept subcritical. But to make it sustain a chain reaction and release a tremendous amount of destructive energy, the plutonium sphere must be at critical mass. Critical mass is the smallest amount of fissile material needed for a sustained nuclear chain reaction. One way to make it critical from subcritical is to compress it and increase its density by 2.5 times. At normal densities, due to the large spaces between atoms, the neutron released from the fission reaction will lose its energy before reaching another atom, and the chain reaction will not sustain. But if the density of the plutonium is increased by more than 2 times, and if we release the neutron, this time due to smaller gaps, the chain reaction will sustain. In Fat Man, the amount of plutonium used was 6.19 kilograms. To make it critical, the sphere had to be compressed to increase its density. This is not an easy task. The pressure required to do so is about 300,000 atmospheres, equivalent to the pressure exerted by 500,000 elephants. Not only that, but the pressure applied should be symmetrical to compress the sphere uniformly. Although it is impossible to arrange 500,000 elephants, it can be done by arranging explosives around the sphere and detonating them simultaneously. But there is a problem. The explosion wave or the detonation wave is spherical. If these spherical waves hit the plutonium sphere, the compression will not be symmetrical. To make the compression symmetrical, the chemical composition of the explosive materials is modified. Instead of a single material, the explosives are made with different layers of fast and slow explosives. This changes the curvature of the diverging detonation wave to a converging wave. This is called the explosive lens. When the explosive lens is detonated, it increases the density of the plutonium sphere by 2.5 times by compressing it. This state of the plutonium sphere is supercritical. At the same time, a radioactive element called polonium-210 releases alpha radiation, which is then absorbed by the element called beryllium. Due to the absorbed alpha radiation, beryllium emits neutrons. These neutrons are mixed with the plutonium sphere. The criticality of the plutonium sphere is reached, and the reaction starts. The chain reaction continues, and billions of atoms are split in a fraction of a second. This generates a tremendous amount of energy in the form of explosion and heat. The next question is, how was this bomb detonated at the right time? A simple time delay is not possible because during the free fall, the bomb can get destroyed. To overcome this, a technique called the radar method is used. A radar is nothing but an electromagnetic wave. When this wave hits an object and reflects back, it can be detected. A radar antenna is fitted inside the bomb. During the fall of the bomb, the radar waves are sent out and reflected back. As long as the distance to the object is 0, it is inside the bomb and the bomb has not touched the ground. But once it touches the ground, the distance is not 0, and the bomb will detonate. This is how Fat Man, a nuclear weapon, was detonated. This nuclear weapon killed almost 40,000 people instantly and caused many long-term health effects. Today, nuclear weapons pose a significant threat to humanity. Several countries possess nuclear weapons, and the fear of a nuclear war always looms over us. It is essential for nations to work towards disarmament and prevent the proliferation of nuclear weapons. Nuclear weapons have changed the world forever. They have shown us the horrifying consequences of their use. Thank you for watching. See the next adventure.